Alright, so picking up where we left off, we're graphing trig functions, so we're just going to be graphing some more. We'll just get right into it. So I have 5 graphs, and let's see what these look like. So this is section 6.3. Today is the 29th. Oops. It's called graphing trig functions. Alright, so let's get into this. Example 1. I'm going to ask you to graph. Say y is equal to -2 times the sine of 2 theta minus 180 degrees. First thing we should do to find the amplitude, period, and phase shift is we should factor out the 2. And see what we get. Alright, now anytime we're going to use theta, we're going to be using degrees now. And anytime we see x, we're going to be using radians. For right now, let's focus on degrees. The amplitude for this would be 2. Period would be the normal divided by the number in front. And then it's going to be 90 degrees to the right. Alright, and let's get our calculators ready. We're going to always use the original when we plug it into our calculator. And see what happens. We'll always start at -360. Store for A, making sure I'm in degree mode. I'm going to type in -2 times the sine of 2a minus 180. At -360, my answer is 0. Because the period is 180, every 180 degrees, it's going to be the same thing. Okay, let's see what happens at -270. I'm going to store -270. And I'm getting 0. Alright, so 180 degrees later, it's the same thing. Now, how on earth are we supposed to graph this? Right, we're added numbers. Well, let's pick some smaller numbers. How about -45 and +45? If we store -45, we get -2. And +45, oops, put it in the wrong spot. +45, we get +2. So at this point, kind of get the idea what the graph looks like. Up, down, up, down, up. It looks like in between we're going up. Now you could always pick more values if you want. I mean, you could pick 135, right? Or you could just add 180 to this, add 180 to this, right? Subtract 180, add 180. Eventually you'll see that that's how you graph, is you use the period to help us get points, and then we connect the dots based on what it should look like. Let's graph one in radians. How about y is equal to -2 times the cosine of x plus pi over 2. There's no number in front, so amplitude, period, and phase shift. Now we are going to be in radian mode, so instead of using degrees, it's not a big deal. We'll just use radians. Remember, 180 degrees is really pi. 360 is 2 pi. And then every 90 degrees, it's really just pi divided by 2, right? 180 divided by 2 is pi over 2. That's pi over 2. This would be 2 pi over 2. This would be 3 pi over 2. This would be 4 pi over 2. And we could fill it in the other side too. You might get a little uncomfortable with radians, but eventually over time, you'll get used to it. Okay, so let's make a table now. We'll be using x. We're going to use the original, -2 times the cosine of x plus pi over 2. Now the period would be 2. The amplitude is 2. Period is the normal period divided by the number in front, which is 2 pi. And we're going to be going pi over 2 units to the left. Now I had given you a table a couple of times in the notes. I'll go back. Right here, right? We said the period 360 degrees is the same thing as 2 pi radians. 180 is the same thing as pi. So you'll get more comfortable with radians as we move on. But for right now, just try to hang with me here. All right? So let's try some numbers. Like let's try -2 pi, which in degrees is -360. If you have to convert, it's not a big deal. Just on your calculator, hit the degree button and convert it over to radian mode. It says RAD. So I'm going to type -2 times the cosine of m variable a plus, and then the pi symbol divided by 2. So I'm going to store -2 pi, hit the store button in A. Everything's the same as what we were doing before. I'm going to ask my calculator to figure it out, and my calculator is telling me it's 0. Period's 2 pi, it's going to be the same thing. 2 pi, it's going to be the same thing. Let's pick another number. Let's try -270, which is -3 pi over 2. I'm going to store that, -3 pi divided by 2, store it for A. My calculator is going to tell me that that's 2. 360 degrees later, it's 2, and 360 degrees later, it's 2. So we should start seeing a pattern here. -pi is -180. If we plug that in, we're going to get 0. And you know what the shape of cosine looks like. Eventually, you'll get the shape like that. All right. A few more here. I think I told you 5 today. So example 3, we're going to be graphing y is equal to the tangent. It's actually not exactly. 4 times the tangent of 2 pi. Or 2 theta. Ay. All right. So the amplitude, period, and phase shift. We see theta, so that means we're in degrees. There's no amplitude because it's not sine or cosine. Normal period is 180, but if we divide by 2, that turns into 90, so this is going to be a little shorter. The phase shift is going to be 0 or none. So get everything ready. And let's try it out. Okay, so I'm going to store that. 4 times the tangent of 2 mem variable a. And at -360, store it. Calculator's telling me it's -2.6. Oh, I'm in radian mode. Make sure you switch to degree mode. And I'm getting 0. Every 90 degrees, it's going to be the same thing. So we're in a little bit of a pickle here. Remember, it repeats every 90 degrees. So I have a feeling the graph's going to look like this. It's going to be kind of like tiny little tangents. Cute. We know that's what the shape of tangent looks like. That's what it would be. Now, if you're not sure where that came from, let's pick like really small numbers, right? So this would be 90 and negative 90. What's going on at 45 and negative 45? Test them into your calculator. I'm getting undefined. And you could see this is like a midget tangent, right? It's like really, really tiny. So every 90 degrees, you get a little tangent. That's what the graph would look like. All right, a couple more and then we're done. All right, so let's see. All right. Okay, number 4, let's graph y is equal to the, say it's negative 1/3 cosine of 2 theta minus 90 degrees. Do something like this. All right, first thing we have to do is get theta by itself. And we'll figure out the amplitude, period, and phase shift. The amplitude would be 1/3. The period is normal divided by 2. Phase shift is going to be 45 degrees to the right. Highest is 1/3, lowest is negative 1/3, so even though it's fractions, it's not super scary. We always use the original when we type it into our calculator. Some people are probably thinking, how do you put a fraction into your calculator? You could just use the division button. Make sure you're in degree mode. Let's try negative 360 first. All right, so negative 360, store for a, and then negative 1 divided by 3 times the cosine of 2 mem variable a minus 90. Comes out to 0. Every 180 degrees, it's going to be 0. Okay, what about negative 270? It's also 0. All right, interesting. So it looks like we're going to have to pick smaller numbers. Like, what about negative 45 and positive 45? I'm getting, at negative 45, I'm getting 0.3. And at positive 45, I'm getting negative 0.3. So I think that answers the question. All right, negative 45 and positive 45. The graph would look like this. Something like that. All right, and we'll do one more. How about a graph that looks like this? Y is equal to the sine of x minus the cosine of x. So this is interesting. We don't have to worry about amplitude, period, and phase shift for this. And let's use degrees for this. Now the highest sine ever goes is 1. The highest cosine ever goes is 1. But it could also be negative 1. So I'm thinking maybe the highest it's going to go is 2 and lowest is negative 2. If you get a 1 minus negative 1. But let's make a table and we'll see what happens. And we don't really know the period, so we'll just have to plug in a few different values here. Maybe we'll even see a pattern so we don't have to plug in every one. All right, so let's see here. I'm going to type in sine of A minus cosine of A. And I'm going to let negative 360 be my A value. I'm getting negative 1. Add negative 270, store it. I'm getting 1. Add negative 180, store it. I'm getting 1. Add negative 90, store it. I'm getting negative 1. Add 0. I'm getting negative 1. So I kind of see a pattern, right? Going negative 1, 1, 1, negative 1, negative 1, 1, 1. So let's see here. 0 is negative 1. 90 is 1. Are going to be 1, 1, then negative 1, negative 1. So I'd imagine the graph looks something like this. Oops, missed it. I mean, think about it. You have a wave, and you have a wave, so you combine those, you'll probably get a wave. And if you're not sure, you could always pick smaller numbers, like pick 45, pick 135, go up by 45s instead of 90. Let's just make sure. So I'm going to store 45, and we get 0, right, which is what we thought. Pick 135, store it, and we get 1.4. So maybe I gassed it a little bit, 1.4. So it looks like maybe we're not quite going up to 2. We're going up to 1.4. So maybe something like this. These kind of problems aren't super important. There's one on the homework, so just try your best. It's similar to what we just did, except there's a plus sign. All right, so for homework, what I would like you to do, I would like you to please do practice 6.3. Don't do number 6. That's not important, okay? Try that out. We will talk more tomorrow.